Hello everybody. In today's video we are going to be taking a look at the solution to the college prep refraction due right now number 2. It's the last time I'm going to be able to do that to you guys. I know you're going to miss it. I'm going to miss doing it to you. Oh, so sad. So sad. All right, let's take a look at our problem here. An even layer of oil floats on top of water, which has an index of refraction of 1.15. A beam of light strikes the oil at an angle of 32.1 degrees to the normal. What is the beam's angle of refraction in the water? So we have 3 different mediums that the light is traveling through. We have air, oil, and water, and we have 2 different boundaries that it needs to cross. It needs to go from air to oil and from oil to water. So we are given the index of refraction of air, which I know to be 1.00. I know the index of refraction for the oil was given in the problem, 1.15. My angle of incidence in the air is 32.1 degrees. And the first thing we're going to need to find is my angle of refraction when it crosses the air to oil boundary. So we are going to start off with Snell's law right here. And solving Snell's law for theta 2 will give us theta 2 equals the inverse sine of n1 times sine theta 1 divided by n2. We plug our values for the index of refraction for air, my angle of incidence, and the index of refraction for the oil. And we do that calculation out. We are going to have a angle of refraction going from the air into the oil of 27.5 degrees. Now to look at the refraction once the beam of light reaches the oil to water interface. So I know that my index of refraction for the oil, again, is 1.15. The index of refraction for water is 1.33. And remember, I don't give you water and air, or the indices of refraction for oil or water and air in the problem, but those you can get off of the table in the PowerPoint or from the formula sheet in the toolbox on the website, or you could just Google them. Now my angle of incidence at the oil to water boundary is going to equal my angle of refraction at the air to oil boundary. They are alternating interior angles. So the angle of refraction from air into oil was 27.5 degrees. So my angle of incidence from oil to water is also going to be 27.5 degrees. And we want to calculate the angle of refraction into the water. Just like the last time, we are going to use Snell's law, and solving that for theta 2 will give us the same formula that we had before. Now we are going to insert the index of refraction for the oil plus the angle of incidence at the air to water boundary and my index of refraction for the water. And when I do that out, I'm going to have an angle of refraction into the water of 23.5 degrees.